Hello, good afternoon.
Good afternoon, sir.
Hello.
Good afternoon,
How
sir.
are you guys doing? Okay, I think we can start now. Good afternoon to you all. You're welcome to PCS 209 class, and that is Business Statistics 1. My name is Professor Adeleke, and today's class is the concluding part of the introduction to the basic concept in business statistics. So last week we introduced the learning objectives, which include basic definition of statistics and business statistics. We have also introduced some basic concepts, and today we'll continue from where we stopped. We'll define more concepts and also differentiate between descriptive and inferential statistics. So remember last week, we have defined statistics. So we have said that statistics is a discipline. It is a field of study that deals with knowledge of data collection, data organization, presentation, analysis, and interpretation. And we have also discussed how important statistics is in various fields. We looked at accounting, economics, marketing, production, finance. So today we will spend more time on defining more of the concept. The first of those concepts is population. So we'll be defining population here as a collection of well-defined objects. Collection of well-defined objects in a target universe. So we can have population of cars, we can have population of students, we can have population of factories, we can have population of workers. So population that we refer to in this course means collection of well-defined units in the target universe. So population can be finite and it can be infinite. In you, the entire blood in you is the population. So when you take a little bit out of it, you have what we call sample. So let's just have it at the back of our mind that population, as far as this course is concerned, is the collection of well-defined objects, well-defined units in the target universe. So another concept that we'll be looking at is sample. Sample. Sample is the fractional part of a population. A sample is a fractional part of a population. That small part that you take out of that population is a sample. So if you go for a medical test and the lab technician needs to take part of your blood to observe if you have malaria parasite, for instance, that part that is taken from you is the sample, while the entire blood in you is the population. So that fractional part, that subset of the population, is what we refer to as sample. So another term that we'll be making use of more often in this course is parameter. Parameter. So a parameter is a function of all the units in a population. A parameter is a function of all the units in a population. Any function at all that represents the entire unit in a population is a parameter. So you can have population mean. The mean is computed by adding all the measurements in the population, and then you divide by the total number of observations that you have in that population. So that function, that mean, that value that you have computed represents every member, every unit of that population. So it's a parameter. So you could have population mean, population variance, population standard deviation, and so on. As long as all the units in the population are used in the computation, then you have it as your parameter. The next is statistic. Statistic. A static function of a unit in a sample. Just as we have sample that is a fractional part of a population, our parameter represents the entire unit in the population. Statistic will represent the entire unit in a sample. So I can have sample mean. Sample mean. The sample mean will be the average of the units in a sample, while the population mean is the average of the units in a population. So parameter goes with population, statistic goes with sample. Then we have estimation. Estimation. So estimation is the procedure by which we compute the value of the population parameter. Estimation is a procedure by which we compute the value of the population parameter. In practice, population parameters are usually unknown and they needed to be estimated. And that is why samples are taken so that that population parameter can be estimated. Imagine you going to the hospital to check if you have malaria parasite in you or not. If you have the information that there's malaria parasite in you, there wouldn't be need for you to go to the hospital in the first place. The medical doctor will have just recommended some drugs, and that drug will clear the parasite in you. But because he is unsure, and that will be the reason why the lab test will be recommended. So it is the lab test that will confirm whether there's malaria parasite in you or not. So the population parameter in this case is unknown, and that is whether or not there's presence of malaria parasite in your blood. So if it is known, there wouldn't be any need for sample. But because it is unknown, that is why sample will have to be taken so that the parasite can be estimated. So estimation is the procedure, okay, by which population parameter are estimated. And one of the ways of estimation is to take sample, observe the sample, and then do your estimation. Okay, so remember we said population is the aggregate of all units in a target universe. When you collect all units together, well-defined unit in a defined location, what you have will be your population. Now, a part of that population, a fractional part of it, a subset of it, is called the sample. And then if there's any computation, any value that represents the entire unit in that population, then that value would be your parameter. On the other hand, if you have a value that represents the unit in your sample, then you have what we call your statistic. So estimation is the procedure by which the value of the population parameter are computed, are estimated. So estimates are the value that you arrived at after your estimation, your result, what your formula yield is called the estimate. While estimator is the formula that have been used in the computation. Estimation is the exercise itself, is the process by which you compute the value of the population parameter. Estimate is the value that you arrived at after implementing the process, while estimator is the formula that you used in the computation. Sampling. So the sampling is a procedure of selecting sample from a population. The procedure of selecting sample from a population is called sampling. I'll take it again. Remember, population is the collection of all units of a specified type in a target universe. It's just collecting well-defined units together. If you are able to collate all of those types, then what you have is the population of that particular type. A part of it is referred to as sample. Any function at all that you can use to represent your population is your parameter, while the function that you use to represent your sample is your statistic. Now, if you need to estimate that parameter, if you need to compute the value, the procedure that you go through in collecting data, analyzing it, putting it together, and arriving at a result. It's called estimation. While the result that you arrived at is the estimate. The formula that you used, either it's a point or interval, is your estimator. So sampling is a process, is a procedure by which you select a sample from a population. What's a sample? Fractional part of the population, this subset of it. So you have finished your cooking and you're about to conclude it. So you needed to check whether your sauce is right. You want to know whether you should add more salt, whether you should add more seasoning. You need to take part of that cooking and check. So that part that you take from the pot is your sample. Now the process that you go through in selecting it is sampling. Sometimes if you are cooking stew, you need to stir and stir and stir. Why are you stirring? You want to ensure that there is homogeneity in whatever sauce, whatever seasoning, or whatever things that you have put together. You want to ensure homogeneity before you take part of it. That is sampling. Okay, so you are running a promo. You want to increase your volume of sales, and you feel running a promo will make more customers to go after your product. You have assured your customers that once you buy this product, you are entitled to winning a prize. So the entries that will that will enable you to win the prize have been dumped in a particular container, and you want to do your selection. The entire container that you have, whether you have it as entries in a database or you have it in a raffle draw box or whatever, those represent your population. It represents the entire entries. It represents the total number of purchases that you have within that time frame. So you wanted to select winners from that entry. The winners that you are selecting are sample from the population. So you might decide to select your winners using some random techniques by ensuring some level of fairness. So the drum will be rolled, will be shuffled, will be subjected to all sorts of random techniques just to ensure that whoever you select as the winner is selected fairly. The whole process that you go through in selecting your winner is sampling. Okay, so any process that you go through for you to select part of the population is sampling. Then we have the sampling frame. Sampling frame. So a sampling frame is a list or a map or any other acceptable material from which sample can be taken. A sampling frame is a list or a map or any other acceptable material from which sample can be taken. So I have finance students, I have ER and HRM students, I have accounting students, and I want to select winners for a prize. So I know it's difficult for me to gather you guys somewhere, but I still want to select from 200 level students. So I can use the broadsheet. I can approach the HOD that I need the list of all accounting students in 200 level. So the HOD might release the list from his broadsheet. So that list will serve as the, so the list contains which I can select my winners from. That list is a frame because I can use it for sampling. So any list or map or any other acceptable material from which I can select my sample from is a sampling frame. Now let's quickly go over the terms again. We started with population. Population. So we said population is the collection, is the aggregate of all units of a specified type in the target universe. So whatever you are pulling together, whatever you are putting together must be well defined, must be known. So I can have population of accounting students, or I can have population of Faculty of Management Science students. In fact, I can even say the population of 200 level accounting students, so if I want to be specific. So the unit of your population must be well defined. Now, you could also be interested in a sample of it, a few out of the entire population. That few is called sample. 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 So a sample is a fractional part of a population. A sample is a fractional part of a population. And then we have parameter. Parameter. So a parameter is a function that represents the entire population. A parameter is a function that represents the entire population. So I can have population mean, population variance, population standard deviation. So as long as that function represents the entire population, it is a parameter. It is a parameter. Then we have statistic. Statistic. A statistic is a function of all the units in a sample. A statistic is a function of the unit in a sample. Statistic. So I can have sample mean, sample mean, sample variance, sample standard deviation. And what it means is that that function represents units in my sample, not in the entire population, in my sample. And then I explained estimation. The estimation is the procedure of calculating the value of the population parameter, while estimate is the value that you arrived at, and estimator is the formula that you have used for the calculation. Sampling is the procedure by which you take sample from a population, and sampling frame is a list or a map or any other acceptable material that you can select your sample from. So you have so many other terms that we need to familiarize ourselves with, which includes elements, variable, observation, and so on. So I want you to please familiarize yourself with all those terms as we move on. So remember, we have defined data last week. We defined data as facts and figures that are collected, analyzed, and interpreted for decision making. That is very key. Now, you don't just collect data for the fun of it. Data are collected to guide decision. So data becomes information at the end of the day after you have analyzed them, after you have summarized them, and you have interpreted them. So, and remember, we have looked at data according to how we source them. We have also looked at data according to its nature. We did that last week. Okay, so there are also other terms like elements. Elements. So elements are entities on which data are collected. So elements could be the individual. For instance, I'm dealing with 200 level accounting students, and I'm interested in your average age. So there's a product that I want to sell, but that product is targeted at some ages. So I needed to find out if your class meets that age requirement. So the elements, the subjects matter here, they are the students. Okay, and I want to collect information from them. What information am I interested in? Ages. And this age would vary from one individual to another. So in that case, my variable of interest are the ages. So ages becomes the variable. We define variable as the characteristics of interest that is measured on the population unit. So what the population unit in this case? The students, the 200 level students. What is the variable? The variable here is the ages, okay? Not that it is a variable because it varies. It is a variable because that is what I am interested in. Of course, it will vary from one unit to another. It's not a constant. When it's a constant, it means that it is the same for all the units. Otherwise, it's a variable. Variable because it can be different from one unit to another. It will vary from one unit to another. Otherwise it will be a constant. Constant because it will be the same for all units. So what you measured, they are your observations. Okay, so you should know all the terms. So these are this is a typical data structure that explains the difference between elements, observations, and variable. Now look at the companies there. Okay, there are 5 companies. They have Dataram, Energy South, Keystone, Landcare, and then you have the Psychimedic. And you are interested in their stock exchange where they are quoted. You are interested in their annual sales. You are also interested in their earning per share. So the variable of interest are the stock exchange where they are quoted, the annual sale, and the earning per share. Those are the variables. And what are the elements? The subject matter. The subject matter are the companies that you want to collect the information on. And what information have you collected? They are your observations. So you have your NQ, you have N. Those are the possible stock exchange that they are quoted on. And then the annual sales, you have them in figures, 73.1 in million, and so on. Then you have your earning per share, 1.67 for Energy South, and so on. This is how the data structure looks like. And this explains the relationship between elements, observations, and variable. So what is different between descriptive and inferential statistics? You know, there are times that when you gather your information, all you are interested in is just to describe that data using graphs, describe that data using tables, or you can just summarize the data using figures. So if your interest is just to describe the data, then all that you are doing will be descriptive statistics. Descriptive statistics. Because descriptive statistics deals with data summary using figures, using tables, or graphs. However, if your interest is to generalize from the sample that you have on the entire population, then you are making inference. If your interest is to compute probabilities, your interest is to investigate the level of relationship, the extent to which one variable predicts the other, then you are interested in inferential statistics. So our statistics could be descriptive and it could be inferential. Descriptive deals with describing our data using tables, graphs, or summary measures, while inferential statistics deals with hypothesis testing, probability estimation, regression analysis, time series analysis, and so on. So if our interest is just to use the information that we have, which represents part of that population, to generalize on the entire population, then you are interested in inferential statistics. So again, parameter and statistic, this is what we have discussed earlier. Parameter goes with the entire population, statistic goes with sample. And what does parameter mean? It's a function that represents the entire population, while statistic is a function that represents the sample. And usually, these are the symbols that we will be using. The symbol here means mu. Mu. Can you see it? It's a Greek letter. It's like a U with one elongated line somewhere. So this is to represent the population mean. It's a population parameter. And then we have sigma. When you square it, it becomes sigma squared. We usually use it to represent population variance. Of course, when you find the square root without the square, that will be the population standard deviation. These are some of the symbols that you'll be using, and we should get used to them. X bar. X bar. Can you see it? X bar. X bar is a symbol for sample mean. S is a symbol for sample standard deviation, while S squared is a symbol for sample variance. These are some of the symbols, some of the terms that we'll be getting used to. Okay, so inferential statistics. Like I said, if you are interested in using just one part of the sample to generalize, just as the lab technician will take part of the blood could be taken from any part of your body. It could be from the tip of your finger. It could be that the lab technician locates your blood vessel and then he takes some blood from it, or it could be from any part of your body. The blood will be subjected to test, and then when there's a positive presence of malaria parasite, for instance, in the blood, a general statement is made that, oh, this patient is malaria positive. So the lab technician wouldn't say it is the hand from where the blood was taken that is malaria positive. No, the lab technician will generalize. From that drop of blood taken from the finger, the lab technician generalizes on the entire population, on the entire blood in that particular patient. That is a typical example of inferential statistics, when you use small part to generalize on the whole, then you have inferential statistics. Okay, so, and this explains everything that was discussed last week, that when you have your data, the data can be quantitative, can be qualitative, can be numeric, non-numeric. I explained all of this last week, including continuous, discrete, ordinal, nominal, and so on. So I want you to get used to all of that, and that will be data according to nature. But here, data according to how you have sourced it will be primary or secondary. Remember, we discussed all of this last week. Primary, if you design the process that generates that data. If you collect the data by yourself, either by direct observation, by experimentation, or when you conduct sample survey, as long as you put up the mechanism that generates that data, whatever you get will be primary. Otherwise, if you have to go to a repository, if you have to go to someone else that have collected that data is secondary. So we discussed all of this last week, and I want to believe that you guys have revised and you have accustomed yourself with teaching. So we discussed different sources of secondary data. Remember, I discussed CBN, I discussed Ministry of Education, NNPC, and so many other organizations. As long as their job also deals with data collection and storing, they are data collection agencies. So if you get information from them, that information will be secondary. But to them, that generates that data, that put up the mechanism for generating it, it will be primary. So these are sources of data: direct observation, conducting experiments, sample survey, and so on. So when you collect data, there are so much that are very that one needs to be very, very careful of and to put into consideration. For data to be relevant, that data must be data that is not obsolete, because the time that you collect the data really matters. If I'm analyzing foreign exchange data, for instance, and I'm using 2005 information for my analysis, that, of course, will lead to misinformation, because many things have changed and the exchange rate are drastically, changed over time. So relevancy, matters, and that has to do with timing. So also the cost of collecting information will have to be considered, especially if you have to determine whether you need primary or secondary data. For secondary data, it is easier for you to access it from a database. Then there won't be any need for you to set up mechanism or start employing people to generate the data directly. So you should also look at the margin of error before you start collecting your data and before you determine the source from where you collect your data from. So all of these have to be put into consideration when you are gathering your data. So when you have your data, there are 4 measurements that are possible. You have the nominal, you have the ordinal, you have the interval, and you have the ratio. All of these will be discussed as we move on in this course. So yeah, we are not discussing all of this right now. So aside from that, I think this is where I'm supposed to stop my class with you guys. My job is just to introduce you to the course and some basic concepts that we'll be using. So that brings me to the end of my part of the course. I'm ready to take your questions if you have any. You can also let me have your complaints if you have any. If you also have observations or just general comments, you can also raise them here. So the floor is open for questions and comments, please. Hello, do you have questions, comments? All right. In the absence of questions and comments, I will declare this class closed, and then I wish you all the best. Bye-bye, and see you soon.